My name is Priyanka Jain and my roll number is 225078 of BSc Maths Regular second year third semester. This is a maths presentation of mechanics and my topic is rocket motion. Rocket motion. The motion of rocket is an example of the system of variable mass, which means mass is not constant. The motion is based on Newton's third law of motion and the principle of momentum. It consists of a combustion chamber in which liquid or solid is burned. This heat of combustion raises the pressure very inside the chamber, so the hot gases are expelled from the trail of rocket in the form of jet with a very high exhaust velocity, and the rocket moves in forward direction. It exerts the force of action on the gas jet in forward direction. These are the internal forces in the rocket and gas system. In the absence of the external forces, the total momentum of the system, rocket and the gas, is constant. The gas jet acquires the momentum in the backward direction and the rocket gets equal momentum in forward direction. Let m be the mass of the rocket plus fuel at any time t and v be the velocity. Let the amount of mass dm is ejected from the rocket in time interval dt in the form of gas jet. If u be the velocity of the gas jet, then its velocity relative to rocket v is given as vr equals to u minus v. This is marked as an equation number 1. The velocity vr is the exhaust velocity. By Newton's second law of motion, we have mdv by dt equals to fe plus vr dm by dt. Here we are marking this equation as equation number 2, where fe is the external forces acting on the system and vr dm is the force of reaction exerted on the system by leaving mass. The force Fe is the gravitational force air resistance on the rocket. If we neglect the air resistance and change in gravity, then Fe equals to mg. Now we are putting this value of Fe in equation number 2. To get this equation, mdv by dt equals to mg plus vr dm by dt. Now this is equation number 4. If rocket moves upward, then v is the directed upward and vr g downwards. Then we have mdv by dt equals to minus mg minus vr dm by dt, implies dv equals to minus g dt minus vr dm by m. Integrating when motion starts at time t equals to 0 with velocity v0 and the mass of the rocket and fuel is m0. Up to an arbitrary time, we get integral from v0 to v dv equals to minus g integral from 0 to t dt minus vr integral from mo to m dm by m. By solving it, we get v minus v0 equals to minus gt minus vr log e m by m0. V equals to v0 plus log e m0 by m minus gt. We are marking this as equation number 5, where t is the time required for the burning all the fuel, m is the final mass, and v is the maximum velocity attained by the rocket. On neglecting g, we get v equals to v0 plus vr log e m0 by m. Thank you.